बच्चों, कैसे हैं आप लोग? आई होप you all are staying at home and following the instructions of the administration against the corona. Today I am going to start your class 12th physics unit 1st electrostatics. Unit 1st electrostatics. In this unit, we will study electric charge, electric force, number 3, electric field, number 4, electric potential, number 5, Gauss theorem, number 6, capacitance. क्लियर? तो इस हेडिंग में इलेक्ट्रोस्टैटिक के अंदर हम लोग पढ़ेंगे इलेक्ट्रिक चार्ज, इलेक्ट्रिक फोर्स, electric field, electric potential, Gauss theorem, and capacitance. Now come to this word electrostatics. This word electrostatic is made of two words: electrostatics. This electro means electro plus statics. Electro means charge. This means charge. Electro means charge, that is electric charge, and static means at rest. रुका हुआ, stationary. The behavior of electric charge at rest. What are the effects produced by this charge at rest? All these things are studied under this heading electrostatics. So we will define this electrostatic as the branch of physics in which we study the electric effects of charge when it is at rest. Why we are applying condition here? Condition of stationary charge. क्यों हम कह रहे हैं ये कि चार्ज एट रेस्ट? रुके हुए चार्ज, जब चार्ज रुका हुआ है, मूव नहीं कर रहा है, उस वक्त उसके क्या क्या इफेक्ट्स हैं वो हम यहाँ पढ़ते हैं. इट मीन्स इट हैज अदर इफेक्ट्स आल्सो व्हेन इट स्टार्ट्स मूविंग. जब चार्ज मूव करना शुरू करता है, चलने लगता है किसी कंडक्टर में, व्हेन इट स्टार्ट्स फ्लोइंग, देन इट exerts some other effects. And all those things we will study under another heading, and that is electrodynamics. But this electrodynamics is the next unit. We will study this electrodynamics later on. These two units combinedly known as electromagnetism. Clear? Electromagnetism is further divided into two parts. electrostatics and electrodynamics. In electrostatic, we study the effects of charge at rest, and electrodynamics, we study the effects of charge when it is in motion in conductor. Now come to this electrostatics. Here you have marked that under this electrostatic we will study about electric charge, electric force, electric field, electric potential, Gauss theorem and capacitance one by one. Now first, this electric charge. Electric charge. Electric charge. Electric charge. It is a physical quantity Physical quantity means the quantity which can be measured. It is a physical quantity due to which electrical effects are produced in matter. Electrical effects are produced in matter. Electric charge is a physical quantity due to which electrical effects. What are electrical effects? Electrical effects like electric force, electric field, electric potential, all these are produced in the matter, in the material body. Unit SI unit of electric charge is coulomb. Here C is small. SI unit of electric charge is coulomb, denoted by capital C. And by capital C. The smallest charge that a body can have is equal to how much? The smallest charge that body can have is equal to, yes, it is equal to charge of one electron. A body is equal to the basic, fundamental elementary charge. The smallest charge that a body can have is equal to the fundamental elementary charge. फंडामेंटल एलिमेंट्री चार्ज किसको कहते हैं? फंडामेंटल एलिमेंट्री चार्ज मीन्स दैट इज चार्ज इक्वल टू that is charge equal to charge on one electron. Clear? If a body gains one electron, if a body gains one electron, then charge on the body, will be negative, and equal to 1.6 into 10 to the power minus 1.6 into 10 to the power minus 19 coulomb, denoted by minus C. Similarly, if a body loses electron, then the charge on body will be plus E. Clear? The body loses electron, then the charge on the body will be positive and it will be equal to plus E. If the body loses one electron, then the charge on the body will be positive, equal to plus 1.6 into 10 power minus 19 coulomb, denoted by plus E. So this is the smallest possible charge. Sometimes we also take the charge on one electron as the smallest unit of charge which can be given to a body. We cannot give charge to a body which is smaller than E. This is the smallest charge which can be transferred from one body to the other body. Clear? Now, we will study the basic properties of charge. Basic properties of charge. Basic properties of charge. Number 1. Charges are of two kinds. Number 1 positive and number 2 negative. Second property you also know that is light charges repel and unlike charges attract each other. Third property is positive charge and negative charge tends to cancel each other. Positive charge and negative charge tends to cancel each other. Understand? What does it mean? For example, suppose a body has plus 5e charge. Clear? And if you give minus 5e charge, then the net charge on the body will be 0. 0. That is the meaning. Positive charge and negative charge tends to cancel each other. If suppose you have a body, it has charge plus E, and you give 3E, minus 3E charge, then net charge will be plus 2E. That is the meaning. The positive charge and negative charge tends to cancel each other. Clear? Now comes to next property of the charge. Next property of the charge is somewhat like this, that is charge have additive nature. Charge has additive nature. Charge has additive nature. Now what does it mean? It means the total charge on a body is equal to the algebraic sum of all the charges on the body. Algebraic sum. When we do algebraic sum, then we take the sign, whether it is positive or negative. We take the sign in consideration, and the positive and negative are taken in consideration. For example, suppose this is a body and you have given plus 2e charge here, minus 5 is here, and plus 4e there. That is, at different parts of this body we have given these charges. Now what is the net charge on the body? The net charge on the body will be minus 5e plus 2e plus 4. The algebraic sum, we will take the sign in consideration. So the total positive is 4 plus 2, 6, and minus 5. So we will have here minus 5e plus 6e, that is plus e. That is, net charge on the body is plus e. This is the meaning charge have additive nature. Clear? Now we move to the next property of the charge. Next property of the charge is number 5, conservation of charge. Conservation of charge. Conservation of charge. That is, charge is conserved. The total charge on a body is conserved. Means we can neither create charge nor we can destroy the charge. Charge only can be transferred from one body to the other. It means the total charge of an isolated system is constant. The total charge of an isolated system is constant. We can't create or destroy the charge. This is the meaning of conservation of charge. And next property is quantization of charge. Property number 6. Quantization of charge. We have studied that the smallest possible charge which can be transferred from one body to the other is equal to the charge on single electron. And we also know that we cannot divide the electron. If we go to divide the electron, then it will not exist. So, if we want to transfer electron from one body to other, then either we can transfer 1 electron or 2 electron or 3 electron, 4 electron. So, the charge on a body will be either plus 1e plus 2e plus 3e plus 4e. That is, if the body loses electron. If the body loses 1 electron, then it will have 1e charge. If the body loses 2 electron, then it will have plus 2e charge. If body loses 3 electron, then it will have plus 3 electron, plus 3 charge equal to plus 3 electron. And if the body loses 4 electron, then it will have charge equal to charge on 4 electron. Positive in nature. And in the same way, if the body gains electron, if the body gains 1 electron, then the body will have charge equal to minus 1e. If body gains 2 electron, then it will have minus 2e. If the body gains 3 electron, then it will have minus 3e. And if the body gains 4 electron, then it will have minus 4e. Similarly, if suppose the body loses n electrons, so the charge on the body will be plus ne, where n is integer. And if the body gains n electron, then it will have minus ne charge. We can't have charge on a body which is a fraction of electron. We can't have charge like this, 1 by 2e, 1 by 3e. This type of charge, the diffraction of a charge on a body is not possible. We can have charge which is integral multiple of e. The charge on a body will be integral multiple of e, like this. And this is the quantization of charge for a fixed amount. The charge can be transferred in a fixed amount, and that is equal to 1 electron. And this is the quantization of electron. That is, the charge on a body will be integral multiple of E. We cannot have charge which is a fraction of E. The charge on a body will be equal to integral multiple of E. That is plus minus 1e plus minus 2e plus minus 3e dot 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 plus minus ne. The charge on a body will be equal to the integral multiple of E. This is known as quantization of charge. This is known as quantization of charge. We cannot have charge on a body which is a fraction of electron. We cannot have charge on a body charge on a body which is a fraction 3e 0.7e, like this. Clear? Now we start scalar form of Coulomb's law. Scalar form of Coulomb's law. Actually, this law is about the interaction between the two charges, whether they will attract or repel. Now, what will be the magnitude of this interaction, this force of attraction or repulsion between the two charges? That was calculated by Coulomb. How much the force will be between the two charges? This law states that the force of attraction or repulsion between two charges at rest will be directly proportional to the product of the two charges and inversely proportional to the square of the distance between the two charges. Clear? So this law states that the force of repulsion or attraction, you can add here, this law states that the force of attraction or repulsion between two charges at rest will be directly proportional to the product of the two charges and inversely proportional to the square of distance between the two charges. Clear? Suppose we have two charges, Q1 and Q2. Q1 and Q2 are two charges. If suppose these two charges are positive, that is, they have same nature, there will be repulsive force. They will repel each other. Let the distance between the centers of these two charges is from here to here. This distance is R. Then the force acting between the two charges, F is directly proportional to product of the two charges, and F is inversely proportional to the square of distance between the two charges. Combining these two, or F is proportional to Q1 Q2 by R square, or F is equal to K Q1 Q2 by R square. Here K is a constant and it is known as electrostatic force constant. K is a constant and it is known as electrostatic force constant or Coulomb's constant. K क्या है? K is Coulomb's constant. Coulomb's constant or electrostatic force constant. Electrostatic force constant. So we have got the formula of Coulomb's law, that is the force between the two charges F is equal to K Q1 Q2 by R square. This is the scalar form of Coulomb's law. This is scalar form of Coulomb's law because here we are not marking the direction. After this we will study vector form of Coulomb's law. The value of this constant K, the value of Coulomb's constant, K depends upon number one, units taken, and number two, material medium between the two charges. The value of this constant K depends upon the units taken. What are units? Are the system of units. In which system you are taking the units, and you can write this as system of units taken. System of units taken. In which system you are taking the units of this charge and the distance between the two charges. This was the Q1 and this is Q2, and the distance between these two charges is from center to center is R. Now the value of this force is K Q1 Q2 by R square, and the value of K depends upon the medium between the two charges. If suppose the medium between the two charges is vacuum, free space, then K is for free space. Free space means vacuum or air between the two charges K is equal, here K is small, you will write K small. K is equal to 9 into 10 to the power 9, and the unit is Newton meter square per Coulomb square. Also K is equal to 1 by 4 pi epsilon naught. Here epsilon naught is permittivity of the free space, and if you are taking a medium, then K will be this epsilon naught. In place of epsilon naught we will take epsilon m, that is permittivity of the medium. The extent up to which the medium allows the electric field line to pass through it. The effect of this charge, which is acting on this charge, depends upon the medium between these two charges, and the effect of this charge depends upon the nature of the medium here, and that is we define a term for this medium, that is permittivity, that is the extent up to which it allows to pass the electric field lines. And this, of course, for free space it will be K is equal to 1 by 4 pi epsilon naught, and its value is 9 into 10 power 9 Newton meter square per coulomb square. And for any medium, any other medium, we write K is equal to 1 by 4 pi epsilon. Epsilon, sometimes we write as epsilon m. Epsilon m means permittivity of the medium. Okay? We will discuss this permittivity in the next lecture. Here just remember the value of K for doing the calculation. I will explain this permittivity in the next lecture. Now we will solve some numerical problems based on this Coulomb's law in scalar form, and when we will study the vector form of Coulomb's law, then we will solve the questions in vector form. Here you can mark the direction also. The direction of this force acts along the line joining the two charges, joining the center of the two charges. The force, whether it is attractive or repulsive, but it always acts along the line. If it is repulsive, then it will act along this line, away, repulsive. And if suppose you have one is positive and other is negative, then the force will be again along the line joining the center of the two charges, but along the line it will be attractive because this one is negative and this one is positive. The force is attractive, but it is acting along the line joining the center of the two charges. So we will do questions. We will do questions on this formula. So we have studied two formula. One is, first formula is charge on a body Q is equal to plus minus NE. First formula we studied Q is equal to plus minus NE. Here n क्या है? Here n is any integer. Any integer, and E is equal to 1.6 into 10 power minus 19 coulomb. Clear? The charge on a body is Q is equal to plus minus Ne. This was the first formula which we have studied, and the second formula which we have studied is Coulomb's formula. That is force of attraction or repulsion between two charges F is equal to K Q1 Q2 by R square. These are the two formulas. We will solve problems based on these two Now write the question. A body has question. A body has 10 to the power. Suppose a body has 1000 extra electron. That is, body has gained 1000 electron from somewhere. The body has gained 1000 extra electron. Find the nature and magnitude of the charge on the body. This is the question. The body has 1000 extra electron. Find the nature and magnitude of the charge on the body. Now the body has gained 1000 electron. Body has gained electron. So the nature of the charge will be negative. The nature of charge will be negative. Solution. Since the body has gained electron, therefore the nature of charge will be negative. The body has gained electron. We know that if body gains electron, then the charge will be negative. Now, how much is the charge? That will be calculated using the formula Q is equal to Ne. Here, N is equal to 1000. E is equal to 1.6 into 10 power minus 19 coulomb. E will be negative because it is gaining the electron. It is going to minus this. Therefore, Q is equal to minus Ne. Q is equal to Ne. You can put the value of this E. 1000 into 1.6 into 10 power minus 90 negative, that is 3 power will cancel out. 1.6 negative 1.6 10 power minus 16 coulomb. Now next question. Next question. Find the force of attraction between an electron and a proton placed 2 meters apart in vacuum. Find the force of attraction between an electron and a proton placed in vacuum. Here Q1 is equal to charge on one electron that is equal to 1.6 into 10 power minus 19 coulomb. Q2 is equal to charge on one proton equal to 1.6 into 10 power minus 19 coulomb. Distance between the R is equal to how much? Distance between electron and proton, R is equal to 2 meters. One thing I want to tell you here, when you will use Coulomb's law, Coulomb's formula, don't put the sign of the charge. During calculating the force, don't put the sign. For example, force F is equal to K Q1 into Q2 by R square. Now you want to find this the force. Q1 is the charge on electron. It is correct that the charge is negative, but you will not put here. We are calculating the magnitude of the force. In scalar form, we find the magnitude of the force. So we will take just the magnitude only. The value of K is 9 into 10 power 9 for free space. This is 1.6 into 10 power minus 19. Q2 is again 1.6 into 10 power minus 19. And R is equal to 2 meter, means 2 का square कर देंगे. Okay. Now here you have 19 minus and minus 38, minus 38, and this is plus 9. So we will have 9 into 1.6 into 1.6 into 10 power 9 into 10 power minus 38 by 4. 4 1 is 4. 0.4. That is minus 38. 0.4. 16 4 is 64. 9 into 0.64 into 10 to the power 29. That is 9 4 is 36. And 9 6 is 54 and 3. 54 and 3, 57. 5.76 into 10 power minus 29. Force, SI unit is Newton. This much Newton. Clear? Okay. Now come to the next numerical.